Let's say we're given a map of a grid that has n rows and m columns, just like the one we have here, and we want to find the number of rooms. So we can define a room such that it is a connected set of dots. So for example, this will be a room, this right here will be its own room, and then this will be a room. So that's how we have 3 rooms here. And then we have walls which separate the rooms. So we have to figure out the number of rooms that are here. And the easiest way to do this is through a depth-first search. So what we'll do is we'll go from top to bottom, and for each one of those iterations, we'll go from left to right, left to right, left to right, and so on and so forth. And for each one of these characters, if it is a hashtag, that means it's a wall, so we're not going to do a depth-first search with that wall. But if it's a dot, that means we're in part of a room. So we can start a depth-first search where we check every neighbor, and the neighbor is going to be defined as either up, left, down, or right. So we check the neighbor, we see if it's a valid position, and if it's been visited before. And if none of these conditions are true, then we can traverse into that position. So for example, let's say we're here, then we can either go up, left, down, or right. And so the only place that we can go is right because we haven't visited yet. So we find that we cover this spot and then this spot. And then once we're at this spot right here, we find that we can go left, up, right, or down. And we can only go left here, but we've already gone left. We've already visited this spot. So that means we stop right here. So this is its own room. Next, we find that we're at this location. So we proceed here, and then we can go here, 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 and here. And then we find that the next position that we can go is right here. But we've already went here. So we can't go here anymore. It's already been visited. So we keep backtracking until we reach this location again where we started, because there are no more positions that we could populate. So this right here constitutes its own room. And then we proceed right here, and we find that we can go in this direction. So we cover that area, and those are the only 2 spots that our depth-first search can cover. And that constitutes the 3rd room. So using a depth-first search, let's go ahead and code this out. Now, in past videos, we've used Python for coding out all the algorithms, but for this particular problem, we're just going to use C++ because it's much quicker. With Python, we could also run into the risk of getting a maximum recursion error. So we'll just start by including the IO stream because we're going to need to get input. So include IO stream. And then I'm just going to define a macro for my for loops that I'm going to use later on. You don't have to do this, but I'm just doing it because it makes it quicker for me. So I'm just going to define for n and m. And I'll say for int n is equal to 0, n is less than n plus plus. For int m is equal to 0, m is less than m plus plus. And for those of you who don't know what macros are, those are just pre-processed directives that C++ carries out. So here it's just going to replace any instance of for n and m with this entire thing right here. Next, I need to create my variables. So I'm going to need to get the rows and columns, the number of rows and number of columns. So I'm just going to say that that's n and m. Int n and m are right here. And then I'm going to need 2 two-dimensional arrays. So one of them is going to be the actual grid itself, or that floor plan. So I'm just going to call it mp for map. So car mp, and I'm just going to set this equal to a 1000 by 1000 array, because I can't actually create a 2-dimensional array and not give any row number and column numbers. And for the purposes of this problem, we're just going to assume that the maximum length and width of our grid is going to always be less than or equal to 1000. Next, we'll just say bool viz, and same numbers here. And this 2-dimensional array is going to represent which locations have been visited by our depth-first search. Now we're going to need 3 functions. So we need bool is valid, and that will take 2 parameters, int r and int c, and we'll just fill this in afterwards. And then the next one we'll need is the depth-first search function. So void dfs int r int c. And finally, we need the main function. So int main, and we're just going to put all our main code in here. So let's actually write the main code first, and then we'll fill in the other functions. So we'll just get input, so sin, n, and m. So this just indicates that we'll have input separated by spaces. And then the next thing is that we have to actually get our elements to fill into the map array. So this is where I'm going to use that defined macro. So I'll say for n m, and then I'll just say sin mp at n and m. So that'll just populate that particular position with this next character. Now before I move on, I just have to actually use this namespace std because I didn't do that before. So using namespace std, and that's why we had this underline here. It's because we didn't actually say that we were going to use that. After this, we can say int count is equal to 0, so that'll maintain our total count, and then we'll use another for loop. So this for loop is actually going to do the depth first search. So we'll say for n m, and then here our condition is going to be if we haven't visited this position before, so if not vis at n and m, and mp at n and m is not equal to a hashtag. And if this is the case, then that means we're at a room position, so we'll increase our count, and we're just going to fill this entire room so that we don't accidentally overcount it as we proceed through this loop. So we'll do dfs n and m, and that's just going to be that position. Now after this, we can just say cout, and then we'll just print count, and then the new line character, and then we're done, so we'll just return 0. Alright, let's actually do the isValid function first. So isValid is going to tell us whether the position that we're trying to go to is valid. So that can just be return r is greater than or equal to 0, and r is less than n, and c is greater than or equal to 0, and c is less than m. So that makes sure that this location is actually in the bounds. And once it's in the bounds, once we know that, we have to also make sure that it's not populated with a hashtag, and also that it hasn't been visited. So and not vis at r and c, and mp at r c is not equal to a hashtag. And we'll just put a semicolon there to finish that. So that's that function. Next, we can do the dfs function. So here we'll just say that whatever position in visited this is going to be true. So vis at r c is equal to true. And then we're just going to span in all 4 directions. So we'll say if is valid. So the first one is we're going to go down. And to go down, we can increase the row by 1 and keep the column the same. So r plus 1 and c. And if that's the case, we'll span in that direction. So r plus 1 and c. And then we're just going to repeat this a few more times. So just like that. And then here, instead of plus 1, we'll say minus 1. And here we'll also say minus 1 because now we're going up. And then for these last two, rather than changing the row, we can change the column because we're actually going to go left and right. So to go right, we can say plus 1 for c and plus 1 right here. And then to go left, we can say minus 1 and minus 1. And just like that, we finished writing our code. So let's go ahead and test this. So we'll take this here and we'll just run this. And I'll just paste in our input. And now we can just hit enter and we see that we get 3. And 3 was the answer that we were expecting. So that's it for this video, and I hope this was helpful.